following on from the previous video, we got to this stage here where rather than you doing this, you can just simply do this, because the way polar integration works is this. You're integrating from an angle of 0, so you're summing up all these sectors here. You're summing up all these sectors here. Hang on. So you are summing up all these sectors here. Hang on. So you're summing up all these sectors here, but rather than summing up the whole sector, you can just simply sum up this segment here, and then you can sum up this one here from the red circle to the blue circle. So rather than summing up this whole thing here, you can just simply sum up all these here. So rather than you doing this whole thing here, you can just simply do this. And so remember, we ultimately we want to find out the whole area here, which we are going to call A. But rather than finding out the whole area, we are just finding out B. So work out B. So B is given by this whole thing here. So when you times it by 2, this thing here will cancel out with this. So the whole area is given by this. So we are integrating from 0 to the intersection of the two. The intersection of the two is here. So we need to find out. So remember, we're integrating from an angle of 0. So we're moving around like this, and then we will stop at the intersection of the two. So we need to find out this angle here. So let's call it theta 1. So we need to find out this angle here. So this angle here is when this radius, well, we call this distance here the radius. We call this distance the radius. We call this distance the radius. So we want to find out when this thing here is the same as this thing here. So to find out the intersection of the two, meaning what angle will the two have the same radius. So set this to be the same as this, and then try and find out the angle here in which this will have a radius of 1. So to find out that angle, set this thing here to be 1. So if this thing here equals 1, then theta equals this thing here. So let's just call the angle theta 1 theta 1 is approximately this thing here. So we are actually integrating from 0 to 3 point from 0 to 1.32, but let's just call this theta 1. Then right at the end we can put this into the theta 1. So the area is given by this whole thing now. So square this thing, square it. That will then give us hang on. That will then give us this thing here. So whenever you want to integrate cos squared or sine squared, you've got to think about something looking, well, to integrate cos squared you would need to put this into here. So that will then give us this thing here, and then 16 to, that will then give us an 8, and then multiply this out. That will then give us this, and merging these two together, that will then give us a 7. So now integrate the whole thing. So to integrate this, that will then give you this. Integrate this, that will then give you this, and then put theta 1 into here. That will then give us this thing here. Put theta 1 into here. That will then give us this. Put 0 into here. This whole thing here will be 0. Put 0 into here. The whole thing will be 0. So that would then take us to here. So remember, right from the, well, remember earlier we said theta 1 is approximately 1.32. So this thing here is this. Well, anyway, the area is approximately 11.16. Okay.